Very good morning, one and all. Myself, Dr. R. Sandil Kumaran, Assistant Professor from the Department of Electronics and Communication Engineering from SRM Institute of Science and Technology. Today, we are going to discuss a very basic fundamental core topic of Electronics and Communication Engineering. It is digital circuits. In our course, we are calling these digital circuits as digital logic circuits. So in that thing, in unit 1, if you discuss already we discussed some k maps, the basic 2 variable k map, 3 variable k map, 4 variable k map was already discussed, right? But today we are going to see a very important topic, that is in the exam point of view it will be definitely these questions will be coming, right? So actually uh, this logic function simplification, we are going for this k map as well as the Boolean law simplification, right? So apart from these two, we are having one more thing, that is a Quine Mccluskey method or tabulation method. So today now we are going to discuss this Quine Mccluskey method as well as the tabulation method or tabulation method. So in other words, you can call it as a Quine Mccluskey or tabulation method. It's a very important one. So actually these things we are using for the simplification of the logic function. The first thing so far we discussed is actually k-map simplification. We already discussed, right? So in class time we discussed this k-map, that is Karnaugh map simplification was already discussed, and the very basic thing is Boolean law simplification. These things was already discussed, yes. So in SOP form as well as POS form were discussed already. So now today we are going to see this tabulation method or this Quine Mccluskey or tabulation method. This is a very important one that you are going to see. Let us have the question directly. I am going to the question. Simplify. The question is simplify the Boolean function, or the minterms was actually it will be given. Simplify the given function using tabulation method. Don't think tabulation method and Quine Mccluskey is different. Both are same. So using tabulation method or Quine Mccluskey method. Whenever you are going for a 4 variable or 5 variable, it is difficult for to get a very lengthy expression. So in order to reduce this, while implementation, it is very difficult. So hence we are moving for this Quine Mccluskey as well as this K-map method, right? So now the question is actually the given function is f is equal to summation m of, that is a min term. Don't call summation m, it is actually a min term, right? So you know very well summation of m represents a min term and pi capital M represents max term. So 0, 1, 3, 7, 8, 9, 11 and 15. 11 as well as 15. So this was the given question. So the question is, I will repeat the question, simplify the given function using tabulation method or Quine Mccluskey method, right? So for this, in order to proceed with this tabulation method or Quine Mccluskey method, first of all we just write the corresponding binary expression. Suppose here the function was not given, let it be, you can consider a b c d. Most probably it will be given. If it is not given, you can consider that as a b c d or w x y z, whatever you want you can choose, right? So what are the given decimal are given? So 0, 1, 3, 7, 8, 9, 11 and then 15, right? So now I am going to represent this decimals into a corresponding binary values, right? So 4-bit representation I am using, because here, so why I am using 4-bit means here you can see here in the question it was given, so the maximum term is 0 to 15. So automatically it comes for the 4 bits is sufficient. So hence I am using only 4 bits A, B, C, D. Right. Now I am going to represent this in a binary values in the 4-bit representation. So for 0, you know very well. So for 0, it is 0, 0, 0, 0. For 1, this is 0, 0, 0, 1. For 3, 0, 0, 1, 1. And for 7, 0, 1, 1, 1. And for 8, 1, 0, 0. And for 9, 1001, and for 11 1011, and for 15 the all ones, right? Just I am writing simply an binary representation, right? You can call it as an binary representation, right? So it's a decimal value, it was given. First step, I am writing corresponding binary representation of the given minterms, right? Now we are going to proceed for step 1. So step 1, right? First I am going to group the minterms. Let us see how we are going to group the minterms, right? First, group, let us give the name group. Then I am going to take minterms. Then I am going to write binary representation. Simply I can write binary rep, right? So the same variable I am considering A, B, C as well as D, right? The first thing, I am writing the first group as G0. G0 represents number of minterms with 0 ones, which means it does not have any ones. So you can see here the first thing, I mean for 0 0 you are not having, only this thing is having no ones. So hence first ticket, then M0, that is minterm 0. So the first group all were zeros, right? Then I am writing the another group. So now you check whether any decimal any binary values you are having without ones, right? So no variable is like this. Then you can close the group. Then group 1. So group 1 is nothing but you are going to write the corresponding binary values. You can write the binary values with 1 ones in the given expression. Okay, so for that you can consider here this M1, right? So this M1, so this term is having only 1 ones. So just write M1 minterm 1. So how many ones are there? Only 1 ones. So 0 0 0 1. Okay, next I am going to analyze any other ones are there. Now look at H. Sorry. Now look at H. So the minterm 8. So M8. Now write under group 1. This represents we are having only 1 ones in the given expression. So 0, sorry, it's 1, right? Right. Now I'm writing for a second minterm, that is M8, which is having only 1 ones. So the thing is, it's actually, so M8 is 1 0 0 0. Right. Now I'm going to analyze whether any one or only 1 ones in the given minterms is there or not. So no ones, no decimal is, no binary values having only 1 ones. Now I'm going to check the other group, that is named as G2. So in that, now I'm going to check how many 2 ones are there. You can see the minterm 3, right? Minterm 3 is having 2 ones, right? Minterm 3 M3. So what is that value? 0 0 1 1. Next check for another, that is M9. So M9 is having only 2 ones. So M9 1 0 0 1. Now I'm going to check for 3 ones in the group, right? Let it be of group 3, that is G3. So G3 I'm going to check for 3 ones. Look number minterm 7, right? I'll take M7. So M7 is having 3 ones. So M7 0 1 1 1, and check whether anything is having a 3 ones. Yes, of course, M11 is having 3 ones. So M11 1, corresponding binary representation is 1 0 1 1. Now I'm going to check the entire thing. Only 4 ones are missing, so that will be grouped as G4. So G4 is equal to M15 1 1 1 1. This was our first step, right? What I done so far, the first thing, I'm writing the group minterms as well as binary representation. In that, I'm grouping as per the number of ones in the given minterms. Okay, so this was the first step. Then I can move to the second step. I just form a table so that it will be easy for you. So as I told earlier, this is very much important one. First step, what I done is, first I'm writing binary representation for the given minterms. Then I'm grouping as per the number of ones present in the given minterms. Right. Then I'll move to step 2. So step 2. Step 2 is the same thing that I'm going to discuss. What I discussed is the same groups, then minterms, then binary representations. The same A, B, C, D, right? So first group I'm grouping G0. Okay, in previous step, that is in step 1, what we did in group 0, we are considering the 0 ones in from the given minterms. Whereas here, now I'm going to group group G0 with G1, which means I'm going to combine G0 with G1 here. So I'm going to verify the minterms, that the minterm is having only 1 bit variation. Now look here, M0 with M0, sorry, M0 with M1, you can see all were zeros here, right? For M0, it is all zeros. Okay, here now I'm going to verify how many bits are varying among the groups. Look at the first group, G0, 0, 0, 0, 0 here. Then G1, that is in G1 group, look at the first minterm M1, so 0, 0, 0, 1. So first bit A is same, B is same, C is same, only D gets varied. So hence in step 2, so in step 2, now we are going to write this as what are the minterms that we are using. So M0, we are comparing M0 with M1. So how many bits are varied? A is same, B is same, C is same, only D is varied, hence it was marked as underscore, right? Now same thing. So I'm going to check here again this M0 with M8. So let's see. So 0, 0, 0, 0 for M0 and for M8 1, 0, 0, 0. The first bit is varied. That is A is varying, B is same, C same, D is also same. Hence I am going to mark this as, so M, what we are comparing. So M0 with M8. The first bit is varying, hence I am marking this as hyphen, then 0, C is 0, D is 0. Okay. So one more thing, now go to first step. Now what are the things were verified? So M0 was verified, M1 was verified, M8 was verified, right? You can put a tick mark. At last I will tell why we are using tick mark. If any of the thing is not grouped, that will be considered some of the implicants, that I will tell. Okay, now we are going to check. So this is now group 1. So how many bits are varying? Only 1 bit was varying in group 0. So M0, M1 are compared, as well as M0, the M8 was compared, only 1 bit was varied. Next I am going for group 1, it would be of G1. Now G1, go back to previous step. So now this M1 can be compared with M3 as well as M9. Next step, M8 can be compared with M3 with M9. Okay, let's compare first M1 with M3. So A is same, B is same, C is varying, D is same, right? So now can I write here as M1, now I'm comparing M1 with M3, right? Go back here. So M1, M3, only first bit is same, second bit is same, third bit is varying, right? So first bit is 0, second bit is 0, third bit C is varying, and the last bit, look at here. So M1 and M3, the last bit is 1. So hence I'm writing 1. Okay, you can put a tick mark over this M3 bit. because we already ticked this M1, right? So tick M3. Next, this M1 can be compared with M9. So first bit is varying, second is varying, third is varying, fourth is, sorry, first is varying, then the remaining B, C, D are same. Okay, so I will include here this with M1 with M9. The variation is the first bit is varying, hence I am marking underscore, but is hyphen, it's actually 0, 0, the next bit is 1, right? Now, this M1 was compared with M3 as well as M9. Now we are going to compare this M8, which belongs to group 1, can be compared with group 2. That is that belongs to midterm M3 as well as M9. So this M8 can be compared with M3 as well as M9. Now check M8 with M3. First bit is varying, second bit is same, third is varying, fourth is varying. So we cannot use this, right? We cannot group this. Next, compare M8 with M9. First bit is same, second same, third same, only fourth bit is varying. So I can use this combination, that is M8 with M9. So M8 with M9 bit. It's actually first bit is 1, second bit is 0, third bit is 0, and the fourth bit is hyphen. Right? Okay. So M8 can be compared with M9. So this belongs to group 1. Okay. Next, we are going to compare with the second groups. Right? That will be of G2. So now this G2 group can be compared with G3. See to that only one bit is varying at A or B or C or D. Right? Now you can check with M3 with M7. So first bit is same, second is varying, 3 4s are same. So I can group this M3 with M7. Okay. Yes. So group 2 M3 with M7. The first bit is 0, second bit is varying, third bit is 1, third bit is 1, fourth bit is 1. Okay. Similarly, now I am comparing again this M3 can be compared with, so this M3 was compared with M7 and we found a 1 bit variation. Now this M3 can be compared with M11. Right, just check 0 0 1 1, here 1 0 1 1, only the first bit is varying. Hence I can group this also. So M3 with, so M3 with M11. Thing is, first bit is varying, second bit is 0, third bit is 1, fourth bit is 1. Right. Go back to step 1. So this M3 was compared with M7 as well as M11. Next, this M9 can be compared with M7 as well as M11. Now check M9 with M7. So 1 here it was 0. So second bit is 0, second bit is 1 here. So almost all the bits were different, right? So we cannot group this M9 with M7. Hence you can group for, now you can check for M9 with M11. First bit is same, second same, third bit is varying, fourth bit, only one bit was varied, right? So M9 with M11. Now you can write M9 with M11. So M9 with M11. The thing is, the first bit is 1, second bit is 0, third bit is varying, fourth bit is 1. Right? Next, the last group, group 3. Go back to step 1. Now we are going to come, so this M11 was, you can mark, tick, put a tick mark at the M11 because it was already grouped. Right? So, you can group with M9 as well as M3. Hence, I put a tick mark. Now, this M7 can be compared with M15 as well as M11 can be compared with M15. Let us see how many bits are varying between M7 and M15. Look at the first bit, that is A. A is varying, then the remaining B, C, D are same for the case M7 with M15. So now this group 3 is M7 with M15. So first bit is varying and all other bits are same. Right? Now go back to step 1. Now you can compare this M11 with M15. Only second bit, that is B, is varying and the remaining bits are same. Now I can write this as M11 with M15. That is 1. Second bit is varying and the hyphen. Third bit is 1. Fourth bit is 1. This is now step 2. Okay. I'll repeat what I did. So after arriving step 1, this we are comparing among the consecutive groups. So G naught, that is the min term M naught with the min terms present in the next group. So the min terms present in first group, that is group 1, is M1 with M8, right? So hence I'm writing here M naught with M1 such that only one bit was varying. Okay. Similarly for group 1, group 2, group 3, right? Next for step 3. So for step 3, the same table I'm going to form: group, matched pair, binary representation. The same variable you can use A, B, C as well as D. Right, in previous step 2, this is actually a matched pair, because in first step it's actually min terms, right? So here we are not grouping anything. Here we are, yes, of course we are grouping based on the number of bits, right? Whereas here we are combining with two groups, so hence we can call it as a matched pair, right? So group, matched pair, binary representation A, B, C, D. Now group 0. So group 0, now the same procedure to be followed. Now we are going to compare this group 0 with group 1. That is the matched pair M0, M1 with M1, M3. Let us see how many variables are varying. The first A is same. Now I am looking for A with, that is, sorry, M0, M1 with M1, M3. So first bit is same, second is same, third is varying, fourth is varying. So I cannot group this. Next, M0, M1 with M1, M9. So first bit is different, second, third, fourth is also different, so I cannot group M0, M1 with M1, M9. Now check the last possible combination: M0, M1 with M8, M9. Okay, 0, 0, 0, 0, 0, 0, 0 hyphen, and for M8, M9, 1, 0, 0 hyphen. Look at these two. First bit is only different, all other remainings are same. Now I'm going to group this. So group, now I'm going to match pair as M0, M0, M1 with M8, M9, right? M0, M1 with M8, M9. The first bit is varying, second bit is 0, third bit is 0, fourth bit already it is varying, right? Right. Next comes to the second pair in group 0, M0, M8 with, now this can be checked with all this group. If we check with this, so M0, M8, compare this with M1, M3, this is not one bit varying. Next check M0, M8 with M1, M9. Yes, of course, only one bit was varying, hence I marked this two. So M0, M8, M0, M8 with M1 and M9. So same thing, first bit is varying, second bit is 0, third bit is 0, fourth bit is already varying. Okay, so now these two were checked with the group 1. Now for group 1, at step 3, group 1, now this entire thing M1, M3, M1, M9, M8, M9, these all three matched pair can be compared with M3, M7, M3, M11 as well as M9 and M11. Okay, let us see M1, M3 with M3, M7. So it is not one bit varying. Now check M1, M3 with M9. So first this one with M9, M11. M1, M3 with M9, M11. M1, M3 with M9, M11. Okay, the varying is, the first bit is varying 0, it's already hyphen 1. Similar way, I'm going to group this with M1, M9 can be compared with this, all these things. M1, M9 is M3, M11. M1, M9, M3, M11. Value is underscore, that is hyphen 01. Right? Now At this stage, this M3, M7 was not grouped with G1 group, but it may be grouped with G3. Okay, now we are going to compare this G2 with G3, right? So now compare M3, M7 with M7, M15. So how many bits are varying? So first bit is varying, second bit is varying, so we cannot group this M3, M7 with the first one. Now I'm going to compare this M3, M7 with M11 and M15. Okay, let it be of group 2. Group 2, I'm going to compare this M3, M7 with M11 and M15. You can see here, so M3, M7 with M11, M15. Okay, so only one bit was varying, first bit is varying. So underscore, underscore, 1, 1, or an hyphen, whatever you want you can call. Next, still this was not grouped, but we have to compare this with the previous, that is M3, M11 with M7, M15, as well as M9, M11 with these two cases. Okay, so now I'm going to group. Yes, now come to check with M3, M11 with M7, M15. You can see first thing is same, second is varying, 3 4s are same. So now this M3, M11 with M7, M15. M3, sorry, M3, M11 with M7 and M15. You can see here the first thing is varying, second is also varying, the last two bits are 1 1. Okay, so now look at step 2. So all the minterms, all the matched pair were ticked, right? So no term was left out. Okay, so now can I write this as now. So this is, if it is 0, it is bar. If it is 1, we can write that as B or A or C or D. So this is B bar, C bar, right? Based on the binary representation, B bar, C bar. This is B bar, D. This is C, D. So these terms, this B bar, C bar, B bar, D, C, D, or we can call it as a prime implicance, right? Which is a prime implicance. Okay. Now we are going to get the simplified expression. Step 4. So step 4, we make a table again. So we are already grouped, right? So prime implicants, then minterms or matched pairs. It's actually minterms. Minterms only we are grouping, right? So minterms. Then we'll have a table. What are the things was given? So 0, 1, 3, 7, 8, 9, 11, 15. You can write those values. M0, M1, M3, M7, M8, M9, M11 and M15. Right. Prime implicants, what we got? B bar, C bar right here. B bar, C bar. Next B bar, D. Next C, D. So minterms, what is the minterms over there? M0, M1, M8, M9. M0, M1, M8 and M9. You can write anything. So both are same only. So M0, M1, M8, M9. This will be M0, M8, M1, M9. Both are right. Right? Both will head getting the same minterms. Next comes to group 1. So this is M1, M3, M9, M11. M1, M3, M9, M11. Next, last CD. So 3, M3, M7, M11, M15. M3, M7, M11. Last one is M15. Okay, right. Now after writing this, just we had a minterm, right? So we had already written from the question given. Just put a mark over there. So the first minterm is M0. So hence put a cross mark. So at M0, no need to round. Okay. This the first minterm is M0. So hence I am marking it as star M0, next M1, next M8, next M9, right? The next is M1, M3, M9, and then M11. The last thing is M3, M7, M11, M15, right? So now look at this. Just make some vertical line so that it will be easy for you to categorize it. So M8 and M9, M11, and then M15. Okay, so this is actually a table. Time implicants, minterms with the given minterms from the question. Okay, line. Okay, now analyze in terms of wherever you are having in terms of vertical wise, how many terms are having in a row, sorry, in a column wise. Just a minute. You have some other color, then only you can able to differentiate it. So now here you can see here only one for M0, for minterm 0 only one thing was mapped, so hence marked that. Now look at M1, so two things you are having star mark, so no need to mark them. Then for similar for M3, whereas in the case of M7 it is only one was marked, so round it. Similarly for M8 only one was marked. For M9 we have two entries, so no need to mark. Similarly for M11 we have two entries, no need to mark. For M15 you will have only one entry, right? Now, so you can focus on the prime implicants now. So whatever value are here, so these things was marked, right? The corresponding prime implicants is B bar, C bar, plus then the other thing is was marked is CD. Wherever you are marking, just look at the prime implicants. So this is your essential prime implicants. Essential prime implicants. So in previous step we found prime implicants, right? So this B bar, C bar, B bar D plus CD are prime implicants, whereas here these are can call it as an essential prime implicants. So the function of the reduced to simplified expression for this given function f is equal to B bar, C bar plus CD. This is your final expression, final simplified Boolean expression, B bar, C bar plus CD. Okay, this you can also be verified with the K-map. Okay, verify with K-map. So I will recall it. The first step, the question was given, so simplify the given expression using tabulation method or Quine Mccluskey method. The given function was given, so in terms in minterms they are representing summation of that represents minterm of 0, 1, 3, 7, 8, 9, 11, 15. What I did in first step, first I'm writing the corresponding binary representation of all these things, right? So I forgot to take this. Okay, for step 1, first I'm grouping, then minterms, then binary representation. Let us see how I'm grouping it. The first thing will be of Z0, which means only no ones were present with the given minterms. So for that you can see M0 is not having any ones. Next for group 1, the minterms that are having only one ones. Next for group 2, the minterms that are having two terms. So similarly write it for group 2, group 3, group 4. Next group 2, sorry step 2, I am grouping this with this M0 with M1, M8. So similar way I can represent such that it will be of one bit, only one bit variation. Such that I am going to group step 2 as well as for step 3. So in step 3 we cannot able to do more than that because we will not having any one bit variation there. So hence this we can call it as a prime implicants. That is B bar C bar plus B bar D plus CD as prime implicants. Then comes to step 4. This time for prime implicants I had noted, then minterms was noted, then this was the given minterms. Then after that I'm just marking what are all the minterms available. So M0, M1, M8 with M9. Similarly I wrote for B bar D plus as well as CD. Then in terms of vertical, I'm looking for whichever column, whichever midterm is having only one entry. So here M0, M7, M8 and M15 are having only one entry. Now look at in terms of row wise. So whatever I marked here, green color, you just mark, look at in prime implicants, that is B bar, C bar. So you can see the second one, B bar D, which is not at all marked. Hence, we just neglect this. So this is not an essential prime implicant. That was a very major thing that to be noted here. And the last one is CD. CD is here, right? So B bar C bar plus CD is an essential prime implicant. This you can also be compared with or verify your answers with K-map. Let us see with K-map, right? So it's maximum value is 15. So we are going to use 4 variable K-map. So A, B, C, D. So A, B, C, D. This is for verification. K-map verification, right? This is 0, 0, 0, 1, 1, 0, 1, 1. Similarly 0, 0, 0, 1, 1, 0, 1, 1. Right? The given functions I'm writing. So M0, M1. The similar way I wrote for all the given minterms. So 1, 1 I'm writing. Right? I will have some other color to distinguish it. Okay. Now I'm going to group the K-map. Right? So as far as our K-map rule, these things can form a group. Right? Similarly, these two ones can be combined with these two ones. So all the elements are grouped. So this can be written as F is equal to, how you can write this? This is an CD plus, now compare this. So first bit is same here, second bit is same. That is B bar, C bar, right? This was, let's verify it with the help of this Quine Mccluskey or tabulation method. Okay, it's a very important thing. It's a very important question. Definitely will get question from this method. Thank you.